Ladies and gentlemen, it's a wonderful privilege to welcome you to this webinar where we focus on a very specific topic. The topic is medical device development and commercialization. On behalf of the Northwest University, welcome, specifically so the Faculty of Engineering, where we have the Faculty of Engineering as home of our theme today. But you'll see it's a home with permeable boundaries and lots of rooms in it. We are in for a fascinating conversation this afternoon. I have two experts from the Faculty of Engineering with me today, and I'd like to welcome them, Professor Leenta Grobler, who will be here today and speaking to us, and then also Dr. Henry Maree. To the both of you, thank you so much for the time that you've given us now and that you've availed yourself for us to talk about this fascinating topic and the incredible work that you have done. Ladies and gentlemen, we're going to start off with Professor Grobler giving us a bird's eye view of the theme today and their work and what they've done. You are more than welcome to post questions. We see all the questions that you post, and we'd love to answer your questions live. So we have two experts here. All the more difficult questions I'll just channel to them, but you're more than welcome to engage with us this afternoon. Professor Grobler, over to you, and thank you. We look forward to what you have to tell us.
Thank you very much. I'd like to start off by giving you an introduction to the Med-E-Hive platform or institute. It is yet to be determined what exactly it will be called, but the group within the Faculty of Engineering focusing on medical device development and commercialization, specifically focused within digital health. As you will see on the next slide, the main supervisors within this research group currently is Dr. Henry Maree and myself. And to give you some background as to how we got to this point, I would give you some indication of my background, and then he'll give some of his background as well. So I am a computer and electronic engineer. I completed my degree at the Northwest University, and then studied towards a master's degree in computer engineering, specifically focused on telecommunications. So for 14 years, I've been focusing on specifically telecommunications, wireless networks, and then also how in the past 6 years, how we can apply that specific telecommunications field to improve digital health and the healthcare system as a whole in South Africa. Henry, over to you.
Yes, well, as you said, you've been busy with this for 14 odd years. I've been at it for a little bit less, about 12. Also an NWU alumni, started my master's degree in automatic identification. At that point in time, it was RFID. And that progressed throughout a doctorate degree in automatic identification for fault conditions in chemical plants. And it seemed to naturally find a home in the medical domain in terms of diagnostics and automatic processing of data. So that's how we ended up sort of combining technologies. It plays nicely towards the new buzzword called the fourth industrial revolution, so-called Internet of Things technologies. And we try and leverage that to better society for everyone, particularly as it pertains to sort of the medical side of things.
Okay. I would like to introduce the experiment that I performed to all of you. And I, on the next slide, will show you how the experiment that I specifically performed was to use a combination of Google and specifically an image search and a VPN to pretend as if I was doing the same specific image search from various places within the world. And I think it will become apparent why I did this. The first image that I found was when I did that specific search from as if I was within the USA. So a public healthcare facility according to a location-specific search in the USA. The next slide is the same exact search performed from a UK-based facility. You'll see that when I move to the next one, that this picture changed dramatically when I did it based from my own home in Potchefstroom. So a South African public healthcare facility, exactly the same words, completely different picture. And on the next one, I performed this search for each of the BRICS countries, so Brazil, India, China, and Russia. And you'll see that none of those pictures come anywhere close to what the typical image is within the two largest medical device development countries in the world. And when you look at the problem in this context is that we in developing countries cannot rely on medical devices being developed in first world countries when even the typical words they would use to search for what it looked like within such a facility if they couldn't travel here was so worlds apart from the typical facilities that Henry and I see on a daily basis and for which we develop some technology. So I would like you to consider this one specific case. We've been developing technology over these 6 years for a host of different problems, but let's take this first one. We have a malnourished child in the top left-hand side. You have a dietitian working within the same clinic as this child is being monitored on a monthly basis. And we have an infantometer that is a perfectly valid way of measuring the growth rate of that child within a clinic. Now, if you look at the current journey that a child specifically growing up in South Africa would encounter, you would firstly see that they encounter queues that would typically involve hours and hours spent per day at the same clinic. Then their head circumference, weight, and body length would be measured. Then it would be written down in a Road to Health booklet that we hope the mother brought with her today. And then we also rely on that same nurse that now measured up to 100 babies today to accurately plot those results on a curve. And then the mother and the baby will go home, and we would have no indication given to the dietitian working in that same institution or that same clinic that have access to those food being aware of this baby. And for the first time that this dietitian becomes aware of this baby being admitted to hospital is when that baby is being admitted to hospital. Apologies. So that baby visited the clinic on a regular basis once a month. Something could have been done before, but now we only become aware of them once the baby reached hospital. Henry, can you identify a few places where human error can make a very big difference and where technology could have been applied in this scenario?
Well, I think if we use your image, you could probably start right at the sort of queuing space. So you've got people queuing, healthy and sick people mixed all together. So there's really no way of prioritizing the really ill ones. That's the first spot. At the measuring phase, measurements prone to human error, both from a recording perspective, since you have to write it down, so there's legibility issues, but also you might have scales with rundown batteries or unit conversion between pound and metric. So that's an issue. Then you've got the booklet that, as you mentioned, they might not bring it with, so we don't have anything to record it, so we've lost all the history. Staffing problems lead to booklets being completed poorly, so now you've got the book, but the history is bad. And then lastly, something that's not explicitly documented in your figures, there's no direct communication path between the nurse performing the measurements and the dietitian. So something that could have been done way in advance and essentially saved a lot of money and saved lives in the process, now is left to fate. So I think there's a lot of places where one could deploy technology quite successfully to address this specific problem.
Okay, so digital technology is currently unlocking a lot of potential within the healthcare space. And while we frequently encounter people telling us that Africa is no place where digitization of healthcare information would be feasible, I would like to show you now what we as a group within the Faculty of Engineering have been doing to address this specific problem. So when we look at the queuing problem, Henry, what did we do? What would we typically implement this year that can really make a difference in that scenario?
Well, we had an honors degree student that focused specifically on the queuing problem. And, you know, in South Africa, we've got many sort of home languages. So we focused on making the thing usable in terms of using icons rather than text. And we essentially classified people. So we split the queue up in terms of what the service was that the person was there for. So that was the one hand. And then we had several honors students over many iterations develop a sort of customized infantometer that automated the recording of the measurements. And that sort of aided the measurement error aspect. And then obviously in the latest revision, we've added some cloud interface to it so that the data is visible to all parties that need it. So it's still not sent along completely automatically, but at least everybody now has access to the same data. And I think that already helps a lot to solve the problem.
Okay, so that is one thing that we would specifically be focusing on in the following year, is to ensure that we close that loop so that we keep a record of who was at the clinic, when did they come there, how frequently do they typically visit the clinic, and then also to ensure that once we have made a specific healthcare worker, be it a dietitian or a doctor or some kind of supervisor within the clinic setting, aware of a certain problem, that they actually act on it. So if they decide to ignore it, we will be recording who decided to ignore this problem, and we can actually fix a set of systemic problems as well. Another thing that I'm very excited about is that since we have this data available now, we can start generating metadata. And that means that we will be able to see what happens within a specific geographic area. We can see if there's a large number of babies within a specific geographic area frequently suffering from malnourishment, then there might be a place where we can actually send appropriate workers to upskill and educate the parents, or to ensure that the resources at the clinic is actually sufficient. We would have real-time data available as to the age of the typical baby. So since every 6 months the typical diet would change, we can make sure that the food available at that clinic is actually suitable to the typical age presenting at the clinic, and we can save a lot of lives, but we can also save a lot of money in the process. And I'm specifically also excited about the fact that we can save time for the people queuing, because I think at this point, when visiting a typical clinic is a day-long encounter, it is something that actually also touches the pockets of those parents taking their kids to the clinic, and it makes it very difficult for them to help the kids. So with that being said, we have identified 5 hot topics in medical device technology that are currently being studied all over the world, and that we are very excited about, that we are tackling it, specifically focusing on the healthcare sector in South Africa. So firstly, that is VR and AR technology, so virtual reality and augmented reality. And while this is a topic that most people only typically encounter within the gaming space, there is huge advances currently in terms of applying this in the therapy space, where people help people who suffer some form of disability or some trauma to recover faster. And specifically, within our context, we're exploring how we can use that in terms of the training of healthcare professionals. Then in terms of 3D printing, while our dear friends at the Central University of Technology have been 3D printing medical implants since the 90s, we are currently also very excited about the prospect of bioprinting and using that to manufacture human tissue from the person, using some of the features and cells from this specific person that an organ is meant for, and increasing or decreasing the chances of possible rejection when it is being used with that patient. And as early as last year, the first mid-ear bone ear bone transplants happened right here in South Africa using the same technology. Then in terms of IoT applications or remote health applications, something significant has happened as a result of COVID-19, and that is that legislation changed within our country to actually allow remote consultations to take place. And once that was introduced, it is really a very short stop from the current consultation process to full-blown remote patient monitoring. Then the image that you see on the screen is an image from a Tesla manufacturing plant, and Henry and I grew accustomed to seeing these kinds of medical robots being featured within engineering. But you can see a striking resemblance between those robots and the typical medical robots that is currently featured in many hospitals, specifically in the USA at the moment. And the main focus of that being in a trauma setting where multiple surgeons would have to do an operation at the same time, and not having access to the patient and just being overcrowded. You can see that this is a typical theater where such operations is happening simultaneously, and it's already working within the same theater complex, but there is again very little added technology needed to be able to perform operations such as this over vast distances, completing these kinds of operations from a different country, for instance, and really making a difference in terms of the specialities needed to actually complete operations such as that. And then finally, in terms of artificial intelligence and machine learning, we can also see that there's a huge uptake in this technology and implementing this in terms of automatic screening and diagnosis being made, since we can deploy this technology in this space. So the themes that we typically focus on within our research group is within these 5 areas of specialty. Firstly, in terms of IoT, We have completed some projects in terms of remote and automatic patient rehabilitation. I'll provide you with some examples of that now. And that enables us to not only increase the capacity of existing physiotherapists and occupational therapists, but also to give them real data in terms of how well their patients are performing, whether they're doing the exercises, and whether the exercises is actually helping them in the process. Then maybe, Henry, you can speak a bit about the medical robotics that we've been spending time on.
Yes, so sort of aligned with this IoT thing where you gather the data, there's a device required to help the person perform the exercise. You've now removed the therapist, so the therapist might be thousands of kilometers away. And we need to find a way to help the human. And one of the main challenges when combining robots and humans is that robots are typically much stronger. So they may hurt you significantly more than the therapist would. And if those of us that's been to a physical therapist, you would agree that it's possibly a little bit painful, but the therapist has a tactile feel. And we spent quite a lot of time trying to mimic the tactile feel that the therapist has by some mechanical means. And I think it turned out well. There's still some work left to do, but we're trying to duplicate that. We've done it for a hand. We're trying to do it for a knee and a shoulder as well.
Okay, so then in terms of 3D printing, I've mentioned bioprinting. Our colleagues within the Faculty of Engineering are currently exploring how we can print 3D print some skin that will make a significant difference in the lives of burn victims. We have a very large number of shack fires in South Africa every single year, and these people are then left with a permanent scar after such a fire. So implementing this technology will make a very big difference in their lives. Then in terms of augmented and virtual reality, I mentioned that we trying to see how we can complement the therapy and training space. So we're currently exploring how we could train nurses for some very traumatic experiences, like the NICU environment, for instance, the neonatal ICU, and specifically the traumatic experience of resuscitating a baby. And that is something that you can't really train for. So we're seeing how we could actually augment that reality and have the students be better counseled through this very traumatic experience. And then in terms of AI and machine learning.
Yes, in terms of AI and machine learning, we've taken an approach that is just another tool. So it's not the be-all and end-all of technology. We have successfully applied it to PCR testing, which is primarily now on everybody's mind as the COVID test. It takes about 24 hours to get tested, but the actual test is 3 hours or thereabouts. But the rest of the time is taken up by a human having to study graphs and to make a classification. Yes, this is COVID. No, this is not. And that's a good fit for machine learning to play a role. Obviously, from a medical perspective, it's under the supervision of a trained clinician so that this thing does not go rogue and make the wrong classifications. But we see a lot of application for machine learning and artificial intelligence in the greater context in the medical sphere as a form of augmenting the abilities of clinicians and therapists.
Again, in the process, saving a lot of time and saving a lot of effort. So we're never planning on replacing any form of medical professional, but we specifically want to enable them to make better diagnoses and have better outcomes. So our aim within this group is enabling data-driven screening, diagnostics, rehabilitation, and therapy within a multidisciplinary team. So we've done this, like I mentioned, for quite some time, and we built a very good relationship with our colleagues working in the healthcare space. So we're not a bunch of engineers pretending as if we're understanding the problem or inventing some problems ourselves that we imagine there being. So we're really working with healthcare providers and co-creating some solutions that can actually integrate quite well within this space. So specifically, when we look at screening and diagnostics, we want to limit the effects of human error. We've used the example of the clinic where human error could have been avoided in very many places. So we can have more accurate measurement, we can do data analysis automatically, and then also report that data automatically. And this is something that we have been, hazard to use the word perfected, but we've managed to do quite well within our group to date. And then our second focus being the rehabilitation and therapy, focusing then on the remote measurement of patient compliance, and like I mentioned, seeing actually what the data says in terms of the success of using a specific therapy for a specific condition. So some examples of some current projects that we're working on. We've worked on several iterations of a hand rehabilitation device for people who suffered some traumatic brain injuries. And like Henry mentioned, this year we specifically focused on how we could measure knee rehabilitation following a knee replacement surgery. And that is a project that we will also continue with quite significantly in the coming 2 years. Then we're also very excited about technology that enables speech and language therapy. Henry, you can maybe speak a bit about that.
Yes, well, my honors degree student is currently working on this, and some background might be worthwhile. Child language development occurs roughly in the first 3 years, and it's primarily driven from an interaction perspective. So how parents talk to children and how many turns they take, and that sort of almost simplistic things, which you would never think about. Interestingly, the speech therapists have no view of that. So they ask the parent, do you speak to the child, and how do you do that? But you can imagine there's even more opportunity for reporting errors, since you're doing a good job as a parent, so but something is wrong. And we're trying to get technology into that space to try and quantify those interactions to better help these speech therapists provide targeted therapy towards a specific situation. And my honors degree student has developed a hardware device that you can mount to a specific child to record these interactions over time. And we've also had another honors degree student working on the software aspect to make the information visible to the speech therapist. So it's obviously providing low-level engineering data to a speech therapist does not really have value. So I think there's always this dichotomy between technology and the user. We as a group tend to spend a lot of effort on bridging the gap. So how to make the data accessible to the medical professional.
And then also the reason why we need to specifically focus on this in South Africa is that, again, these kinds of technology do exist in other places in the world, but they are typically developed for English-speaking countries only, and they do not cater for the small nuances in the very diverse cultural environment in South Africa, and Afrikaans in Pretoria and Afrikaans in Cape Town not even sounding the same. So we could buy some technology from overseas, but it will never be as good as something that we have tailor developed for our own market. And then we were also very lucky to work on a number of COVID-specific projects. So some of you might be aware of our digital health screening data collection solution, Chop Chop. And then also, we have also been involved in 2 others, one of which we can mention at this time. Another one we will be sharing with you in the very near future as soon as the patents are filed. But many people, or all of us, have been flooded with this information about the ventilator shortage within South Africa. And very few people realize that there was a crisis behind this crisis, that we could develop as many ventilators as could be made by the factories. But the crucial resource within this environment is actually the nurses having to monitor those ventilators. And we see that their skills cannot be transferred in a short period of time, and they are also the most exposed. So we have our most critical resource at the wrong place at the wrong time, and therefore we have been working on a remote ventilator monitoring solution that will not only protect these resources, but that can also be monitored over large distances, that can be used with a very wide variety of types of ventilators. And again, this makes it possible for pulmonologists, for instance, who monitor patients with severe acute or with chronic pulmonary disease that have to undergo oxygen therapy at home, to see whether they're actually administering their oxygen as they should, and then also whether it's working or not. So we can again have a lot of information that is currently just based on a patient being honest. And in this interaction, we got to become part of the MERSETA VIRO-VENT Skills Innovation Challenge. And that is something that is very specifically important to students that would like to join us in the coming year, because as part of this consortium, as a whole, we are developing a ventilator as a team of the 5 institutions. We are developing a BiPAP ventilator, and then our solution, our remote ventilator monitoring solution, forms part of that solution. But in the process, we are actually determining which skills within the South African environment didn't exist prior to 2020, and we're filling that gap, and we're creating the learning material and ensuring that we upskill people currently working, but then also students who would like to function within a medical device space. So students joining us within the following 2 to 3 years will get that added exposure when they join our team, because these co-created short learning programs will be an added benefit that would not have been possible in the past. And then our dream is to establish a 4IR-enabled therapy surveillance center. We said that we're focusing on developing technology for the allied health sciences in addition to pharmacy and nursing. But it's one thing to travel to a clinic on a daily basis or to travel there frequently, but it's a totally different experience when you form part of that team. And Henry, you can maybe elaborate on how having such a facility that we're currently applying for funding for can make a difference in terms of the technology that we develop.
Yes, well, I think, as you mentioned, it's one thing to travel to a clinic, but it gives you a little sip of the water. And in order to develop products that really fit in and solve a problem and is usable, we need to understand the interaction between the therapist and the patient. And in order to do that, you need a little bit more visibility than being the third person in the room, since that's just sort of creepy. So then the therapy doesn't work. So we need to sort of hide in the walls, and we think that technology can be used to accomplish that, so that we can get a really good idea of how a therapist and a patient interact, so that the stuff that we develop fits into that context. Since you don't want to have the therapist perform a whole host of technological trickery to make things work, And similarly, you don't want to overload the patient even more with new and additional things that they have to do in addition to the therapy that they intend to achieve. So I think that's what we would like to eventually establish, is a facility where one could do that. Obviously with all the required permissions and that sort of thing, but that you really dig into what the interaction between the therapist and the patient is, so that technology that we develop can actually be used. So I think that would probably be the saddest thing, is if we develop all this nice technology and it ends up on a shelf somewhere classified as it's too difficult to use, it doesn't really work, it falls apart, and that sort of thing.
Yeah, so I think that's something that we can really address quite easily if we could have such a facility. So many people were wondering how this group fits together within the Northwest University, and it is currently hosted within the Faculty of Engineering and hosted within the Unit of Energy and Technology Systems. So we're a formal group, but not a unit in own right, like the Unit for Energy and Technology Systems currently is. We hope to grow into that in the near future, but there's a number of puzzle pieces that we currently developing that will all fit together. And this is a very large ecosystem of role players that have already signed up to be part of this endeavor. So we have, if you look at the image on the left-hand side, you will see that there's quite a large number of institutions outside the university currently. So IP lawyers, clinical trial facilities, product registration companies that have all registered their interest to be part of our technology creation process and to be part of this solution from the very beginning. And then I mentioned already that we are a multidisciplinary team. So while the two of us are situated within the Faculty of Engineering, we are not the only engineers working within this space. We have other colleagues that might not necessarily focus on this, only focus on this, but that add as co-supervisors to the team. And we also have a large number of co-supervisors from the Faculty of Health Sciences that join on specific topics where they can add some value. So while the team over there looks very big, you'll see that the first track is a technology need and fit track. So I specifically enjoy immersing myself within the therapy and medical space, spending a lot of time at the clinics and spending a lot of time with the healthcare workers, observing them quite closely and translating their ideas or their problems to something that an engineer can typically understand. My area of expertise is user experience design, and that is also why it is so important that I really get to know my user very well. Then our second one is the product development track, and Henry has a special interest there, since I typically hand out my technical challenges to Henry, who then takes the problem further.
Yes, so in the product development track, we've got certain subspecialties. So you'll have mechanical engineers, industrial designers, embedded developers, since you need to realize that a medical product is much more than just electronics or just a box. It's everything coming together at the same time and working together nicely, all the while satisfying the need that you've identified from an observation perspective. So I think there as well, we've got a diverse team of skills, since you won't find a single person with all the required skills. And I think that's key to the groups, that we need the diversity to manage things.
Exactly. We then hand over to a data science group, who then typically focus on what can we learn from the data, what can we do with the data, and how we can improve some processes once we are aware of certain trends within the data. And then the last two is then taking this as an almost academic answer. I think we pride ourselves on not sticking to just the theoretical solutions, but actually bringing them up to prototype level. then taking that prototype that we've developed and taking it to market. So you'll see a number of companies listed there, but then also our technology transfer office at the university form part of each product that we develop, from the ideation phase right through to where this product now needs to be licensed to some companies. It might be very big companies currently working within that space, or where it makes sense to make a startup out of a specific technology. They are also part of the team to ensure that we actually reach the people with the solutions that we come up with. Okay, so we, of course, since we're a research group within the Faculty of Engineering, we have a scientific focus, and we specifically want to develop low-cost, high-impact devices that can be used not only in South Africa, but in all of the BRICS countries, where you've now seen my Google experiment at the beginning of this webinar, where we can see similar problems existing in developing countries all over the world. So making sure that the technology we develop is actually usable in other developing countries as well. And then we want to do this not just because we think it's cool and important. We think it's very cool. We love our jobs. But we want to use this technology to really make an impact. We believe that digital health can make a huge difference in the lives of people in South Africa. We will also want to do this because we would like to create some jobs. And then in the process of training you as a postgraduate student, we want to develop the human capital so that you can actually take this technology and this sector forward within South Africa. We want to improve the international knowledge base so that the Americans and the Brits and the people in Europe actually realize that their solutions is cool, but it's not really translatable to all contexts. Thank you. And then also we want to facilitate the whole process of coming up with new technologies. So to assist some people who might be doctors, or that person sitting in a queue in the clinic with an idea to reduce that queue, since he really understands sitting in that queue, to assist them in developing their ideas into products that can actually bring in an income for them in the future. So now you may ask, where do you fit in and how do you become part of our team? And the first question you might have is, who can join us? Now, typically in the past, we've had much more restricted resources than we have at this point in time. So typically we only accepted master's degree and doctoral degree engineering students in the past, but we're now at, and that included both students from computer engineering, electronic engineering, industrial engineering, and mechanical engineering. But at this point in time, if you see a fit for yourself within our team, we would like you to motivate how you think you can make a difference within our team. So that goes for other engineering disciplines, but it also goes for people from the allied health sciences. We won't turn you into an engineer, but we can definitely help you achieve a degree within your specific area of expertise with a more technological focus. And you will work as part of this multidisciplinary team, maybe with a teammate developing the technology, but you really informing it and seeing how this will fit into the health science world. So if you would like to apply, please send us an email no later than 30 November, since we have a limited number of bursaries available, and we would like to make a decision during December so that people can make their decisions for the coming year. So send along a cover letter with your motivation as to why you would like to be part of our team, how you think you can make a difference, and where you would think you would like to fit in. Your latest CV, also your latest academic record, and a copy of your ID document. You send that via email to me personally, and I will confirm receipt of the documentation, and then also information on the process going forward once we've made a decision. Apart from some postgraduate bursaries, we also have some contract-based jobs available. So we can employ, at this stage, mostly computer and electronic engineers. But if you report that you have a specific skill set that we think might be useful in one of the projects that we're currently working on, we might have a job for you that you can complete either as a vacation work for undergraduate students or students who haven't completed it before the end of their degrees, or then on a more permanent basis during the course of the following year. So with that, we welcome some questions from you, and I think we spoke a lot, so now maybe you can ask Henry a lot of questions.
No, don't ask me long.
Both of them. Ladies and gentlemen, you're more than welcome to post your questions. Let me start off with the very start of your presentation, where you depicted the very real situation that we experience in South Africa, that is of a vast difference in comparison to what we see in typical first world countries. So let's get real. You're doing wonderful work, and every little thing that you do augments the whole healthcare environment that people find themselves in and that people struggle in within South Africa. But will we really make a difference in South Africa? I mean, in BRICS countries, yes, some of them are well developed and they might welcome it. But I mean, getting into the South African healthcare system, will we see a relevance? Will we see an impact?
I think so. It's not a case of lack of money. So there's enough money going around to support this. All of the technology that we develop has a low-cost focus. But by low cost, you don't mean cheap necessarily. It's like possibly fall apart. But one of the main difficulties is, and possibly due to some historic reasons, it's very difficult to get people to believe you based on, I can do this. So we need to show them that, well, we've developed a solution that actually works in a clinic. And I think we've, in the last few years, made some strides towards that end, where it's not just talk, it's, well, we'll show you. And that would start gaining traction. I think as soon as people start seeing that it can work better, then there'll be a sort of a groundswell demanding that, well, those guys are doing better, so we want to do better as well. And so there's an inherent thing about people not trying to be bad at their jobs, but they've been sort of managed there due to circumstance. If you worked in a clinic and you had to see 100 patients an hour, you'd manage to do that, but the quality won't be very much. So I think I'm definitely positive.
Yeah, there's a natural tendency to resist change, right? So when massive technological strides in enhancing your performance and your day-to-day life kicks in, it's so massive that there's a natural resistance to change. And I tend to agree with you then that you first have to see it and experience it.
And I think the reason why we have more potential to actually make a change in South Africa is because we're involving the people that are actually supposed to use the technology in the creation of the technology. So it's not
it's
solutions.
Not you sitting in some other lab,
exactly.
and all of a sudden we're going to see machines take. I'm hearing the theme music from Terminator now in my head.
It's not a technology push. So if people require more intelligent scale that perhaps can just tell you the batteries are flat, then that's what we'll deliver. That's what would increase the adoption. So it's not a case of, we've developed a super fancy thing and we're going to dump it there. Something that almost no one thinks about, but you can visit any government clinic and this will be the case. There will be some technology that's been dumped by a European grant or a US grant and nobody to maintain it. You know, the thing died. We're not sure what happened. Soon it starts gathering dust. It's stuck in a corner, an ancient relic. It might be the best technology in the world, but you have to balance there's no one to maintain it. So our capacity development theme is not only capacity development for building the devices, but someone's got to maintain it. And you need to keep the maintenance aspect in mind when you develop it so that you don't need a rocket scientist to go and maintain the thing. So I think it's very much a case of the homegrown angle is almost, you cannot get past it if you want to be successful and really understanding people's problems. It takes a lot of time, but if you get it right, then I think you build a very, very functional solution, which people actually want to use.
Well, you're touching on something that I want to get to next, and you've mentioned it actually before. It's such an engineering thing, but closing the loop, you know, that closed systems controls it. I think it's an electrical engineering thing, you know. The whole system, you need to be in control of it. But now we're working with policymakers, health practitioners, etc. So there are so many different stakeholders and role players involved in your work. I mean, I jotted down a few ideas here, and the scope of what you deal with is just incredible. To get control, it's almost like a hermeneutic thing that you have to go and see and then come back. It's you'll never stop. You'll be doing this until you die.
Well, possibly. But one should remember, although we're doing this in the South African context, if you split the population in terms of BRICS countries and non-BRICS countries, there's much more people in the BRICS side of the equation than the first world countries. So there's really an impact to be made worldwide. But in saying that, I can fully expect that doing something in China or Russia would be vastly different to doing it here. So the same methodology would apply, and possibly to a large extent the technology. But getting the person inside that, so that loop that you spoke of, critically important, but getting the person in the loop on board, that's almost the most important bit. And they have to feel part of it.
Linda, you've mentioned you've been to a few clinics now and you love going there and getting the hands-on empirical data and seeing what's happening there. How thus far have you experienced a buy-in from all these different stakeholders that you have to work with?
I must say that it is overwhelmingly positive. We've been in talks with the Northwest Provincial Department of Health over the past week in seeing how we can more formally introduce engineers into their environment, and they are actually welcoming at this stage. We've been doing some pilot projects with the School of Pharmacy, specifically in the Tlokwe sub-district in 2019, and following the success of how the people within the clinics in the sub-district actually experienced our being there and our wanting to make a difference. The request actually came from their side as to how can we be part of the solution to healthcare within the province. And then what it was also very good to know is that South Africa have developed a digital health strategy for the following 6 years. So in achieving that, digital health is actually a very, very important topic that needs to be studied throughout the country. So I think it's the right thing at the right time. And I think that people are actually seeing the potential benefits.
Yeah, I mean, it's such an exciting field. It's opening up now. So I can think you want as many postgrad students as possible because the themes and the research topics are just limitless. You've mentioned that you've moved from, I mean, the South African language environment's very difficult with multi-linguistic implications all over the place. So you've moved from language to icons. So, I mean, we've been talking about engineering humanities, but even from a humanities perspective, engineering, health, and humanities, where you look at the pragmatic use of semantics and language.
Exactly, and that's why we're also very excited about our recent interaction with SADILAR, which is the South African Digital Language Resources
at the NWU.
At the NWU.
Yes.
And we're so excited about them actually wanting to form part of the team and actually also sponsoring some of the development in terms of the tools that we'll be using for this communication interaction tool. We've also linked up with the child language unit at UCT, specifically focusing on child language development in South Africa. That is also a specific child language focused node of SADILAR. So we've met very interesting people from a whole host of disciplines.
And you'll continue to do so.
Exactly.
Because the scope just grows.
And we really welcome that. I think the only way in which we can actually make a difference is if we work together. And I think if any time have proven that, I think this year proved to all of us that no university can do it alone, no discipline can do it alone. And when we pool our resources, we can do a lot more in a lot shorter time. And I'm really excited about the walls being broken down between disciplines and also between institutions in digital health specifically.
In order to address the problem.
Exactly.
So however which way you structure what happens at the institution of learning, you need to address the problem. Which brings me to the qualification. This is an engineering qualification, right?
Well, engineering education, if you come from an engineering background, if you come from an allied health background, it would be allied health. So we're not sort of doing alchemy and transforming qualifications. So that would be stretching it a bit. So it remains in your core specialty once you join up with our team.
All right. So now we're talking a master's in engineering, which is of course the first focus, but we're also talking MSc. We're also talking MA if it goes to the humanities.
If there's scope for it, then obviously we'll partner as far as possible. So our focus of not trying to be doctors also holds for not trying to be graphic designers or artists or anything else. It's the synergy between the two. So in many cases, engineers are able to wield technology that, especially with the child language thing, we pitched a really simplistic idea and it was a new world that opened up. So all of a sudden the linguists came up with, we can do this and this and this and this, and if we just had a device. And from our perspective, the device was really kind of simple. It's not the most complicated thing from our perspective. And I think that illustrates one small aspect of this, that you need the other side. And so, yes, it would be open to anybody that can slot in and make a difference in one of the areas that we're working with.
Lynn, I'm going to come back to you now. I just want to ask something about the qualification first. I'm going to ask you about metadata and the management of healthcare, the value of the metadata when it comes to management. But when you typically enroll now for a degree that would be within your field, how long would it take? Is there a specific focus area assigned to you? Do you approach the experts and say, listen, what do you have? I just want to be part of this, or how does it work?
It could work in many ways. Due to our group having limited resources, at this point in time, 2 engineering supervisors, we do have a list of projects that's sort of themed and batched. And we feel that that would make sense to also enable students to have greater success than either working on your own, or cracking out a new field on your own is quite difficult. So the projects that we've set out for next year has a defined background, there's some history, so there's some momentum, and we both have experience in those specific projects. So we're not setting up someone for you're on your own, especially with regards to masters. For PhD students, it's a different kettle of fish entirely, but for master students, we have a list of projects. We are flexible, obviously, so if you come with a really good idea and say, well, I've got this idea for machine learning and it fits within context and it's risk managed. So we don't want to set up students for failure based on a good idea. So it has to be a good idea, scientific merit, and fit into the focus. But you would ideally pick off a list, but we would entertain suggestions. Say, well, could we do this or could we do that? And perhaps we might find a solution somewhere in the middle. So some of your ideas, some of ours, and get from.
And also open for different methodological approaches.
Yes.
And I mean, I'm thinking the traditional qualitative, quantitative, but then also a sort of a triangulation going on between the two, etc. You're open for all of that.
We're open to that. And then also we've specifically never envisaged that we'd be the main or only supervisors of students joining our team. So if you, for instance, joining us from a health science background or a humanities background, you will have your main supervisor within that faculty. They will get, you will get the funding, so they will get a funded student joining our team. You will maybe be sitting within the Faculty of Engineering, since we want the group to be located together, either at this point digitally or physically, hopefully someday soon, but to be able to interact quite a lot and learn from each other. But then it doesn't mean that we're stealing students from other faculties. Okay. They will still be, the research outputs will be shared, so the supervisors being involved will actually benefit their own faculties as well. And that is our main aim, is that we don't want to hog a specific area and say that only we can work on it. We want to be this to be an enabling environment where anybody can contribute, but that we learn from 2020 and collaborate and work together towards a common goal.
Which now brings me comfortably to the metadata, which is quite often a management tool and so valuable in determining, I mean, the example that you've given was on a day-to-day example thing, allocating resource and so on. But there's also a strong strategic value in the metadata, right? So we're moving towards healthcare, leadership,
informing policy and stuff like that. Yeah, definitely. So we hope to actually enable government to make better decisions, to make informed decisions, so that it's not based on the opinions of a specific person within the area or the people that he or she knows, but that decisions can actually be made based on real data and a quantifiable difference being made afterwards.
I think I want to recommend cloning yourself so that we have more of you, because immediately I'm thinking on AI on the metadata. I mean, how do we best channel to the relevant leader and the relevant decision maker the relevant information?
Yeah, so if there's someone watching with an idea as to that, please contact us and join us. We need you on our team.
But perhaps that would be a good example of something that would be difficult to fund immediately, since it's metadata. So you need to gather the data first before you have the metadata thing going. And I think in many cases, that's also the issue with policy stuff. So it's not that the policy is bad. There's no way of implementing the policy or measuring if it works at all. So we keep on changing the policy levers, but nothing changes on the ground. And you sort of see that quite often. Once a new minister rolls in, the policy changes. It's not that the policy was bad. There was no visibility. We couldn't manage it. We couldn't measure it. I think the metadata speaks towards that, but you need to put in the hard yards first to actually get there.
Now, we've mentioned the magic word bursaries a little bit earlier as well. And I know at the Northwest University, we have a wide scope of bursaries available. It can be an academic merit bursary, but as you've heard now, we have specific bursaries available for specific projects as well. How does that work? Is it when they contact you, Prof, do they state that, listen, talk to me about bursaries or what?
Typically when a student asks whether they can join a team, they immediately ask whether there's funding available. We realize that most parents can maybe afford a first degree, but subsequent degrees are often very difficult for parents to fund or to fund from another loan that needs to be taken out. So we, yes, you report that you would like to join our team. If we've had a couple of students saying that they actually prefer to be self-funded because they don't want added obligations during or after. Our bursaries typically don't have added obligations after completing the degree, but they may have some number of hours that you need to complete working on a specific technical component that's maybe not specifically in line with the research aspect of the master's degree, but an enabling technology that needs to be developed. Henry mentioned the language recorder, for instance. So since we couldn't just use a cell phone to record the data, the speech data, or a normal speech recorder, we had to develop a very specific recorder that could be used to measure this communication interaction. So that would typically be something that the student joining the team would have to develop and maybe oversee the electronic manufacturing part of it. So there would be hours allocated as an addition to the normal research work that needs to be done. But after completion of the degree, you won't have any other obligations from our current funders. If we were to get some industry funders in future that have specific requirements that you go and work for them afterwards, that might change, but all the bursaries we have available currently have only while you're busy with the study that you do some additional work. And then one important thing to take note of is that we'll pay your studies first, and then we'll give you specific goals on a 3-month basis that you need to reach. So you will receive the rest of your bursary in 3-month stages based on your performance. So if you stop performing or stop showing up to perform your research or fail to submit whatever deliverable you contractually agreed to, then your payment will be delayed until you have completed that work. So that is something to keep in mind.
Sounds even an industrial engineer thought of that process.
There's one aspect that you didn't touch on, and that's sort of we have some, and this will be periodic, so not always the case, but we have some contract work positions that pops up. So it's not a full-blown academic master's study. It's a case of you've got some electronics development skills, we've got some electronics that need development, and that's a natural fit. So it's a much more contract-based approach. Okay. And I think that might be something that's worthwhile for students exploring that do not want to commit to a 2 years master's program, but they would like to gain some experience in this medical devices field. And I think that's one nice opportunity that I don't think other research groups have placed on the table yet.
All right, so I'm going to put both of you on the spot now. I'll give some background information first to give you time to think. But I want to know from you, what is the next big thing that you're working on now? I know you've given us a bird's eye view, but there must be some juicy project that lies in front of you now that you can't wait to just jump into and work. So whilst they think, ladies and gentlemen, you have the contact details of Professor Grobler now on this webinar. But you're more than welcome to contact us at the Northwest University. We'll put you in contact with the right people and we'll really assist you with your postgraduate studies. It'll be a nice fit between what you want to do and what we can offer. Visit the Northwest University's website, and there you'll also see some contact details and lots of space for you to interact with and to engage with us in getting hold of us and helping us help you in the end. All right, let's start with Dr. May. Doctor, it might be something you're working on now, it might be something that you're waiting to work on, but what's next?
Well, we're currently working on, but I can't share that since it's tied up in a patent.
I also wanted to share that one.
That's not a good answer. So I think the way I see it is there's a lot of opportunity to get engineers to solve problems. I think we've delivered engineers for too long that simply do run-of-the-mill things. So delivering engineers that solve problems, not only for Africa, but the whole world. And the stuff we're working on is just a vehicle. So I think that's what's exciting to me, is that we can really deliver people that can make a difference and apply skills that they would otherwise perhaps not have done.
Interesting. You've left it open enough for interpretation. Thank you, Doctor. Professor, from your side?
I'm specifically excited about the very big difference that we're going to make within the speech therapy space. From a personal point of view, I've experienced both bad and very good speech therapists, myself as a child, and then later on with my own child. And I think that is actually what got me interested in the whole digital health space, or healthcare in any case, is that I saw what the difference, the experience that a therapist had could make in terms of the experience and the results that you get from a therapy process. So it was my plan this year to actually work on the speech therapy project, the communication interaction tool myself. I was supposed to go to Emory University and work with the team there and develop it, and then COVID. So I really hope that since we're allowed to travel again, that sometime soon we could actually get that going and make a significant difference in the futures of many kids in South Africa. Your literacy skills later on in life is directly linked to the very early childhood communication between a parent and a child. And that is also something that will, in the end, make the biggest difference in terms of the future of that child and the future of our country. So I'm very passionate about that specific topic, so I can't wait to focus on that.
Well, I tell you, if ever there was a time and a place for people like you, it is now. May you be blessed with the work that you do. I hope that you get many people who strengthen your hands in whatever way you need them. Thank you so much for what you came to tell us this afternoon, and may you have success on that.
Thank you very much.
Ladies and gentlemen, that concludes our webinar. As I've said before, you're more than welcome to contact us about this and many other topics at the Northwest University.